Hello GCC Chem 107 students. This is the second video in Chapter 8 on drugs. So in the United States, we categorize our drugs into 5 schedules. As you can see, the first schedule is drugs that do not have accepted medical uses in the United States. In other words, they're illegal. They have a very high potential to be abused. So they're not used for anything. They're illegal drugs like heroin, federally, marijuana, MDMA, and LSD, or just some of those. Now, Schedule 2, 3, 4, and 5 can all be prescribed by a doctor. Schedule 2 still has a very high potential for abuse, but there are some accepted medical uses with some restrictions. There is the potential for psychological and physical dependence. This would be opium and opiates like morphine, codeine, oxycodone, cocaine, amphetamines, barbiturates, PCP. Schedule 3, not quite as abused, a little bit better, not as potentially addictive, just a moderate level of addiction. These are a lot of your codeine preparations like codeine cough syrup, anabolic steroids again. Schedule 4 has a pretty low potential for abuse. They have a lot of accepted medical uses. Darvon, phenobarbital, tranquilizers, Valium. And then finally, Schedule 5 has the lowest potential for abuse. This is codeine, inhalers, cough medicines, things like that. But again, these are all prescription drugs. We're going to talk about some categories of drugs now. The first one is NSAIDs, NSAIDs, NSAIDs. These are your pain relievers. These are over the counter as well. So NSAIDs are non-steroidal anti-inflammatory drugs, the most common pain relievers in the world. They've been used since 400 BC. We had Hippocrates, a famous doctor, make tea with willow bark. The willow bark tea helped lower fevers, helped with pain and inflammation. It was considered the wonder drug. That's the molecule there. And now we know what those lines mean, don't we? A derivative of this is still in use today. What's the earliest pain reliever? What do you think? What one has been around for thousands of years? Any idea? Aspirin. Aspirin has been around for a long time. Salicylic acid is the drug extracted from the willow bark. The problem is some individuals get stomach problems with aspirin. So now we have a new derivative that we use. Acetylsalicylic acid is aspirin. It was synthesized by Felix Hoffmann and patented by Bayer back in 1893. Back then, in 1893, aspirin did not receive FDA approval, the Food and Drug Administration approval. Why? You're right if it said, we didn't have an FDA back then. No, we didn't. So it didn't need their approval because we didn't even have one. So Bayer came out with aspirin. Now the funny thing is, if aspirin had to go under FDA approval now, it wouldn't pass. It would be prescription only because of the stomach problems it causes. So if it actually had to go through FDA approval now to be over the counter, it wouldn't make it. It would be prescription only. Can you imagine aspirin being prescription only? Yeah, it was kind of grandfathered in when the FDA approval process started. So again, there was no approval process at that time. If there had been, aspirin wouldn't have been approved for over-the-counter, but just for prescriptions. How aspirin works, and a lot of drugs, what they do is they interrupt communication from our body signaling our brain, such as pain. When we have a damaged cell, and it's going to send a signal to our brain saying, ouch. So what NSAIDs can do, like aspirin, they can interfere with that communication so it doesn't hurt as much. It tells our brain it doesn't hurt as much. So aspirin blocks something called COX, and by interrupting that signal, it lets our brain know it doesn't hurt as bad. That's basically how a lot of drugs work, is they stop the communication. It's a little more complicated than that, but they stop the communication process from the cells up to our brain telling us something hurts. Other NSAIDs include acetaminophen. Acetaminophen you may know by the brand name Tylenol. That's the one on top. Ibuprofen is another NSAID. That one you may know by Advil and Motrin. That's the one on the bottom. And now we know what those lines mean. Everywhere there's a line, there's a carbon at the beginning and the end of that line. And then the one that's more recent is naproxen. That's known as Aleve. So the NSAIDs are basically aspirin, Tylenol, Advil, Motrin, and Aleve. So acetaminophen reduces fever, but it doesn't stop inflammation. So if you have swelling, Tylenol is not the NSAID to take. Ibuprofen is even a better pain reliever and fever reducer than aspirin, and its anti-inflammatory action is 5 to 50 times that of aspirin. So if you have swelling, ibuprofen, Advil, is a good one to take. It's also good at pain reliever and fever reducing. So aspirin, however, does something the others don't. Aspirin is the only one that inhibits blood clotting, which is why a lot of people take low-dose aspirin to prevent heart attacks and strokes. But aspirin should not be given to those who bleed easy. So if you have ulcers or if you're going to have a surgery, you can't take aspirin. Even if you've donated blood, you're going to donate blood, you should not take aspirin because it makes your blood thinner and you'll bleed more. So you should only take low-dose aspirin if your doctor tells you to. All right, so that's enough about NSAIDs. Moving on. Next category of drugs we're going to talk about is antibiotics. In 1928, Sir Alexander Fleming saw in a petri dish that had bacteria that an area that was contaminated by a mold penicillium was free of bacteria. He concluded the mold is inhibiting the bacteria to grow. The actual 1929 image by Fleming for his publication is right there of the petri dish. The area at the top is penicillin, and notice the bacteria is less prevalent up at the top. Now over there is a line drawing of penicillin, and you can see it's a pretty complicated molecule. It has some nitrogen, hydrogen, sulfur, oxygen, and carbons, of course, in it. It's a pretty complex molecule. So this is basically where antibiotics come from this accidental discovery. So antibiotics. The purpose of antibiotics is to stop bacteria from spreading, not viruses. Antibiotics will do nothing for a virus. However, inappropriate use of antibiotics causes bacteria and other microbes to mutate, so the antibiotics don't work against them anymore. So the more we use antibiotics and things that contain antibiotics, the more the bacteria are going to fight back and mutate. Because we have antibiotic overuse, a lot of bacteria have become resistant to even the most powerful antibiotics available today. That's not good for us. We are getting superbugs, if you will. There are people who've gotten really sick from mutated bacteria and really sick, even died because bacteria have mutated so much that the antibiotics can't fight them. So we need to not use antibiotics as much as we do. And antibiotic soap, really not a good idea. We don't want to put that in our water. It causes all the bacteria to mutate. And another category of drugs is steroids. Steroids all have a 4-ring backbone, like those 4 rings. Steroids are chemicals, hormones, that your body makes naturally to help your organs and tissues do their jobs. Some examples of steroids are cholesterol, estradiol, testosterone, and cortisol. Steroids can also refer to man-made medicines, anabolic steroids, and corticosteroids like prednisone. So steroids. Corticosteroids are used to treat asthma, allergic reactions, rashes, COPD, and arthritis. Anabolic steroids are man-made versions of the natural steroid testosterone. Anabolic steroids are prescribed for low testosterone and for low muscle mass due to cancer or AIDS. However, anabolic steroids can be very abused. Long-term usage results in a low sperm count, infertility, mood swings, and anger. There's a line drawing of cholesterol. So everywhere you see a point where a line ends, there's a carbon atom. So lots of carbons, and then add in the hydrogens, so they have 4 bonds, so lots of hydrogens. There's estradiol, testosterone, cortisone, corticosterone, and prednisone. As you can see, all of these steroids have the 4-ring backbone. So they all have something in common. Sex hormones. Estradiol is the predominant sex hormone present in females. It is present in males, but at a low level. Estradiol is produced in the ovaries and the testes. It's the main estrogen. It promotes female characteristics like the female cycle and widens your hips. Testosterone, on the other hand, is the predominant male hormone. It is secreted in the testes. Women have a little bit of testosterone as well in the ovaries. It's the main sex hormone in males. Regulates male characteristics like facial hair, the Adam's apple. Anabolic steroids are man-made versions of this. They build up bone and muscle mass. Men have about 8 to 10 times as much testosterone as females. Statins, new category of drugs. Statins. These are used to lower cholesterol by inhibiting the enzyme HMG-CoA reductase, which controls the speed of producing cholesterol in the liver. So statins lower cholesterol. There's the molecule. Pretty complicated, right? Lots of carbon atoms. That's what that means. Lovastatin was one of the first statins to come out. It occurs naturally in oyster mushrooms. That is the one pictured on the left side. So you can just eat oyster mushrooms. That'll help with your high cholesterol. Mevastatin was the next one. It occurs in red yeast rice. You can buy that rice as well as oyster mushrooms in a lot of pharmaceutical stores like CVS Pharmacy, stuff like that. So if you have high cholesterol, you might want to try some of these natural remedies first, like the oyster mushrooms and the red yeast rice. Then the big statin came along, Lipitor. You've probably heard of Lipitor. Sales topped over 10 billion a year for years until it finally went generic. Other statins, Zocor, Crestor, Pravachol, Votorin. Now there's some indication that statins may actually help a little with Alzheimer's, prostate cancer, hypertension, preventing heart attack and stroke, which is what they're supposed to do, dementia, and colon cancer. So there may be some added benefits of taking a statin, but none of those are proven yet. So Lipitor is the big one, and statins lower cholesterol. And I think that's where we're going to stop this video. Pick you up on the next side when we talk about opium. Goodbye, GCC.